I am Martin Searhouse. I'm the director of the Nissan Research Center in Silicon Valley. The NASA technology developed for interplanetary robotic exploration provides the foundation for a trusted infrastructure for autonomous vehicles here on Earth. There needs to be human input. We need to have control. Vehicles need to be coordinated by a technology that we call seamless autonomous mobility, SAM. Vehicles will run into situations where they need help. The vehicles will have to interact with other human beings. And to do that well, and to do that in any situation flawlessly, we believe that a system like SAM will create this seamless integration into human society. It is like the air traffic control system. Thousands of airplanes in the air with 2 pilots in the cockpit, and still we have humans at a distance controlling and observing the airspace. We will need the same for autonomous vehicles, regardless of how smart and how intelligent those vehicles are. I believe deeply that we need this technology to bring fully autonomous vehicles into society. What this technology allows us to do is to advance autonomous vehicles to the next level. And the development of SAM allows Nissan's intelligent mobility concept to transform society and make it a better place for everyone. ProPilot is Nissan's autonomous vehicle technology. SAM enables thousands of vehicles with Nissan's ProPilot technology to drive in society without problems. Things will occur in the world that the vehicle cannot solve by itself. At that moment, the human steps in and helps it. Once he's done that, the system has learned to deal with this, and then it can distribute this to all the other thousands of vehicles out there to solve the same problem without the human in the loop. Thousands, if not hundreds of thousands, millions of vehicles all over the world can be helped this way.
I'm Melissa Sefton, and I'm a principal researcher and a senior manager at the Nissan Research Center in Sunnyvale. Under normal conditions of an autonomous vehicle operating autonomously, they should be able to navigate intersections, crosswalks, all sorts of different settings, obviously all that we have mapped and are familiar with. Nonetheless, there are going to be occasions that it does encounter obstacles or challenging situations that would cause it significant pause, that it will need some additional support. With the help of SAM and an external operator who can quickly assess the situation and understand what's happening, they can send a new recommendation to the car about what it can do to move seamlessly through an encounter. We look globally to understand how vehicle systems, how road systems and everyday practices on the road vary in place to place. When we went to Japan, one of the most remarkable and notable things are narrow roads. Cities have them, rural areas have them, so you encounter situations that you have to negotiate with everybody else on that road. And we're using this to build out a responsible and what we call socially acceptable approach to autonomous systems. SAM is really going to allow us to have profound sort of interaction and teaming between the machine and the people in the system who are helping guide it, so that things can work to the benefit of members of society who are trying to achieve things through mobility. What's exciting about SAM is that it's going to allow us to have many, many cars on the road that are benefiting from the human intelligence in that system. It has built into it a capability for real-time learning. Because you have different operators and people in the loop, they can very quickly propagate an understanding of what a situation was, how to address it, and what to move to in the next instance in a real-time fashion at scale so that we can get autonomous vehicles in a systemic way on the road sooner.